video we are going to discuss about the number system. What are the number systems? How different kind of number systems are there? Now we are dealing with a complex number. Complex number is our target because real number many numbers know, but we just try to compare all kind of numbers whatever you have studied so far, and then we'll brief you about the real numbers, and then we'll go into the complex number. Our target topic is complex number, but the many people do not understand what are the other type of numbers, the real numbers. I have seen many people asking the question that what are real numbers, like that. So first I would like to explain that, starting with the number system. We have a set of numbers called as natural numbers. Natural numbers are also called as counting numbers, and they are represented like a set n such that x is a natural number. X is a natural number. Now if you want to write this in the tabular form or in the roster form, then you can write n is 1, 2, 3, 4, dot dot dot, and there is no ending, because for every natural number x in this set you can always find its successor just by adding 1 to it. That is called as natural numbers. So it is infinite set. So the number of elements of this set you can say uncountable or undefined. Now you go for the whole numbers. Whole numbers are represented with the set W, and they are called the whole numbers. It goes like 0, 1, 2, 3. Like you can say that if in the set of natural numbers, if you include 0, then the number system will become whole numbers. Then we have set of integers represented by I or Z, and this is the whole numbers along with the negative of the natural numbers, like this. They are also non-ending. Now if you want to express them, these numbers, on the number line, then this is your number line. Then you have 1, 2, 3, 4, 5. These points are the number, and there is nothing on the left of this number 1, and there is nothing in between the number 1 and 2. The same thing is true for whole numbers also, but you have to start with little, you can say like that. So 1, 2, 3, 4, 5 and 6. Now you go for the integers, then you can say these are integers, and this is 0. So 1, 2, 3, and that you can say positive infinity, and this is negative infinity, -1, -2, like that. Then the next number we come across are called as rational numbers. Rational numbers. Rational numbers are the numbers of the form, they are represented by letter Q. So they are the numbers x such that x equal to p over q, where p and q are the set of integers, q not equal to 0, and p, q are co-primes. What are co-primes? The co-primes means the numbers which have 1 as the only common factors. If you take any numbers like the 2, 5, 9, 11, 13, then you know that every number is divisible by 1, and by all the numbers are divisible by 1. These are the factor trees. So this is your, every number is divisible by 1. But this number is divisible by 1 as well as 2. Every number is divisible by 1 and by itself. So this number is divisible by 1 and also by 5. 1 by 9, 1 by 11, 1 by 13. But if you try to understand, look at this number, then this number is also divisible by 3. Means apart from 1 itself, this number is also divisible by 3. So this number is called, these kind of numbers are called as composite numbers. These numbers are called as composite numbers, and these numbers are called as prime numbers. And they always begin with 1. 1 doesn't fit into, many people think that the 1 is also prime number, but the 1, because here the 1 and itself, because if you take 1, then this idea means the 1 and itself, these two are creating ambiguity. That's why this has been rejected from the very definitions of the prime numbers, that a number divisible by 1 and by itself. But here the 1 and itself both are the same numbers, but in all other cases the 1 and itself are different numbers. So that's why this has been omitted from the basic definition, and we assume our prime numbers begin with 2, 3, 5, 7, 11, 13, like that, and they are also infinite. And it is assumed that, it is not assumed that this is a nature, that all the numbers which are composite are all numbers which are either prime or they are made up of the prime numbers. So now the rational numbers, P and Q should be co-primes, means between P and Q there should only be one factor common, that is 1. So like, if I say that I have taken two numbers 5 and 6, so this has two factors 1 and 5, and the 6 has factors like 1, 6, 2 and 3. But if you check them, then you have only 1 is common between them. So the 5 and 6 can be called as co-primes. So the number 5 and 6, where the 5 is also integer, 6 is also an integer, and 6 is not divisible, 6 is not 0 even, and then you find that the 5 and 6 are co-primes, so this number is called as rational numbers. So rational numbers are just like that. You take any two numbers from this number system, that is our Z, just pick any two numbers. Suppose I pick minus 2 and 3. So minus 2 over 3 or 3 over minus 2, which can later be written as minus 3 over 2, because in standard form denominators cannot be written as negative numbers. So that's why the minus 2 over 3, these two numbers, both these numbers are rational numbers. So if you pick any number, suppose if I say that I pick only minus 5, then minus 5 can be written as minus 5 upon 1, that is also. So all the integers are rational numbers, but 0 is also rational number, because 0 can be written as 0 upon 7. By definition these two are integers, 7 is not equal to 0, and so this definition you can discard. So all the natural numbers, this integer numbers, are actually the rational numbers. So when you have the rational numbers in the form of fraction, the two type of situation can arise, because you are dividing one number by another number. So the two type of situation can arise even in the situation number 1. The number, I suppose I pick any two numbers, I suppose I take 15 and 7. Case number 1, or if 15 divided by 7, or 7 divided by 15. So if you divide 15 by 7, you can get a proper decimal number as the answer, or you can find a situation where the division is not terminating, it just keeps on happening, just like the case of 2 by 7 or 1 by 3. So in the case of 1 by 3, we generally write it as 0.333333, like that. 3 is recurring many times or repeating itself without stopping. So these numbers are written as 0.3 recur, and or you can say 0.3 bar. And these numbers are called the recurring numbers. That means they are non-terminating but repeating itself. And these numbers can easily be converted back into the fractions. But there are one numbers, like suppose instead of 7 by 2, if I take 7 by 2, then you are getting a terminating decimal number, like 7 by 2 division stopped, and you got your answer as 3.5. So this kind of number, like when you're dividing a number, then you have three situations can arise. Either a number is perfectly divisible, like suppose if I pick two integers values from this number line, like 16 and 4. So case number 1, 16 by 4 I can find, and then 16 by 4, 4 is 4 can divide easily 16, so I can get my answer as 4. And if I go for 4 by 16, then I get my answer as 4 1 by 4, and that is coming as 0.24. So we get three situations: one where the number is completely divisible, 1 by 4 where the number is completely divisible but you're getting quotient in decimal numbers, and 1 where the division is not stopping only, that's called as non-terminating but the repeating continuations of the definition of the division. So these kind of numbers are represented as the recurring, but they are always non-terminating but repeating, so that's why they always recur. Another kind of number is called as irrational numbers, and irrational numbers are the very vague and the very weird numbers. They are called as irrational numbers, and they are actually irrational, means there is no rationality in those numbers, and we define them the numbers which are non-decimal numbers, particularly which are non-terminating and non-repeating. So like that, 0.01, 001, 00001, 00001. So I am just trying to make it like that. I'll keep on writing like that. And this number, you do not find any repetitive pattern here. And these numbers are irrational numbers. Pi is also irrational number. Square root of 2 is irrational number, because if you try to find square root of 2, then you will find that this keeps on happening and you do not get a repeating numbers or repeating patterns. They cannot recur. So these numbers are called the numbers which are non-terminating and non-repeating. So this is all about these numbers, and all these numbers collected together, they are called as real numbers. So the real numbers are all these numbers together, they are called as R, that is real numbers, and their number line goes like continuous value. So you get 0 here, this is from minus infinity to infinity, and there are infinite numbers or numbers. Suppose if you take a number like 0, 1, 2, then the 0 is the real number, 1 is the real number, and the 2 is real numbers, and between 0 and 1 there are infinite number of the real number. This is called the Cantor-Dedekind density, real density number system, which says that between two real numbers there are infinite numbers. How can you say that? So if you want to find, then we know that the average of two numbers, whatever kind of numbers you pick, the average of two numbers always lies between them. So like if you have a number A and B, then the average A plus B by 2 will always be lesser than B and greater than A. So the average of two numbers lies between them. So in this case, suppose if I take that 0 and 1, this is 0, this is 1. What is the average of 0, 1? 0.5. This is the one number you have found. Now average of 0 and 0.5 is 0.25, and average of 1, this is 1.5, this will become 0.75. Like that, if you keep on doing that, then you can find the infinite natural numbers, because this is never going to stop finding out the average between these two numbers. That's why it's called the Cantor-Dedekind real densities property. It says that between two real numbers there are infinite numbers. And when you draw the number line, then you draw the numbers line. Suppose if I say that I have to plot a number between -5 and 7, then you find that you always get a continuous number like this, because between two real numbers there are always infinite numbers. This is all about the real numbers. Now after a break, after cleaning this whiteboard, I'll come back to so now you studied the real numbers. Now we are going to discuss about the complex number. Complex numbers are a special kind of numbers, and how the idea of the complex number came to the minds of the mathematicians of that time. Like suppose when you are solving the situation, because they come across a situation that when you are solving the equation, like solve x square minus 4 equals 0, then how do we solve? We just try to factorize it into the linear factors x minus 2 and x plus 2 is 0, and then we get a situation like product of two numbers is 0. So product of two numbers is 0, so three situations arise that either 0 into 0 is 0, 0 into 0 is 0, but we do not take this as a valid reason because this defies the very basic rule that the division of 0 is undefined. So if you accept 0 into 0 as 0, means indirectly you are accepting 0 is 0 over 0. But the division by 0 is undefined, that's why this concept is also undefined. Both these are, you can say, infinite undefined situations. Undefined situation, like you never get any answer. So when you find a dot b, then we get a is 0 over b or b is 0 over a, and in this condition here b is not equal to 0 and a is not equal to 0. So like if a dot b is 0, means we are assuming either a is 0, we call it like that, either a is 0, like either x minus 2 is 0, and at that time I am assuming that the x plus 2 is not equal to 0. So if x minus 2 either is 0, it means x is 2, or if x plus 2 is 0, then x equal to minus 2. So we get the two real numbers, and this is the answer for this solution. These two numbers are the real numbers, and this equation is you can say an equation or the real valued functions which takes in some real numbers and gives out some real numbers, and this solution is called as the real solution because both answers are real numbers. Now what happens if the number system becomes, if the equation becomes x square plus 4 equals 0? You can never factorize it like that. That's why because x square equals minus 4, you cannot find even the direct root. Like suppose here if x square is 4, then you can find x is plus minus under root 4. But here x is plus minus under root minus 4. This is also undefined number, like this you never get the answer. So mathematicians decided that if they fabricate a new idea, that if they assume that under root of minus 1 is I, and this is called as iota, means that is a very small tiny number and its value is under root minus I and it's represented as I, then this x becomes x equal to plus minus 1 into 4, and we know that the square root of a into b is always square root of a into square root of b. So this number will give me plus minus under root minus 1 into under root 4, and here I'll get, this is I and this is 2, so I get plus minus 2i. So the idea of this iota gave birth to a new number system, and that is called as complex number or imaginary number. Now the standard complex numbers are the complex numbers that is z is represented as a plus ib, where a is the real part and b, like the a and b both are real numbers. Both are real numbers. If you have this a0, then you get the number like ib. This is called purely imaginary. And if you have z equal to a, it is called as purely real. So this idea gave birth to the new mathematical domain, and that is called as complex number. Now let me clear the screen and then I'll come back to you to explain you. Then we have I mean to say that we have the number system, we can call it number system, and it has two branches. One is called real number system and other is called as complex number. Complex number has the huge application in the field of engineering, in the electrical circuits, in the three-phasor diagrams of the electrical circuit, AC circuits, simplification of the AC circuits, all where control system in the electronics and the system and the signals are all based on the complex number. But we are not going to study those engineering mathematics, maybe later I can explain you that, but right now we are focusing on the complex number. So we have complex number Z is A plus IB, where A and B are the real numbers. Now before that I would like to say about this iota, that is iota is under root minus 1. So if you just square it, then you will get I square is minus 1. Just multiply I again, or you can say cube this one, then you get I cube as minus I. If you again multiply both sides by I, you get I4 is 1. Again if you get the I5, then you get I, that is minus 1 under root. So it means this number, if you keep on multiplying, then it will be going from under root minus 1 minus I1 under root minus 1, or I can call it as I. So you can have the situation like the I is I square is minus 1, I cube is minus I4 is 1 again. So I minus 1 minus I1 I, just like that. So like we can conclude the situation that whenever you have a number system, I to the power 4 is 1. So suppose if anybody interested in finding out what will be the value of I to the power 2005, so you can write as I to the power 2004, because this number is perfectly divisible by 4 dot I to the power 1. Now this you can write as I to the power 4 whole to the power 501, and this is I. So this is 1 and I, so this is I. That's why using this concept you can always find the values of I if they are given the higher orders of the I. This is all in this video, and in the next part of this video we'll discuss about how to deal with the complex numbers, how to add complex number, multiply complex number, divide, and what are their significance and what kind of questions we are going to deal in dealing with the complex number. Thank you very much. Subscribe to our number, keep sharing, and then with others if you are interested, if you want others, if you think this video is valuable, definitely you can do that. Otherwise whatever comes to your mind, you are free to do that. This is a free country, man.